Okay, so today's lesson, we are going to be taking what we learned yesterday and applying it to multiplying with scientific notation. So yesterday we multiplied powers with the same base. When we have numbers in scientific notation, we have powers, all powers of 10, so 10 is the same base. So we're going to multiply with scientific notation. We'll look at some real-world problems using scientific notation. And then this last objective is kind of interesting, choosing what units you're going to use with scientific notation. You probably did problems like this back in elementary school where you would pick, like, would you measure a pencil using centimeters or meters? There are those kinds of questions. And in case you don't know what the things mean, I will actually give those to you. So we're looking at really large, really big things deciding, or small things deciding what units we would use. Okay. So we already looked at this rule when we talked about our activity lab. When multiplying numbers written in scientific notation, you're going to use the commutative property. And remember, that's the one that means it doesn't matter what order you multiply the numbers in. So you're going to multiply, I called it the main numbers instead of the first factors. So you're going to multiply the main numbers, by which I mean not the powers of 10, the other numbers. And then you're going to add the exponents of the powers of 10. Now what happens a lot of times is we have to rewrite the answer, because in scientific notation we can only have one digit to the left of the decimal, so sometimes we have to move our decimal and adjust our answer. And that's going to happen with our first one. If we multiply the main numbers, 5 times 9 is 45, times 10, we're going to add the exponents. 6 plus 3 is 9, so we have times 10 to the 9. The problem with this is that number is not in the correct form of scientific notation, because we can only have one decimal to the left of the decimal, one number to the left of the decimal. So I need to move my decimal over one place to say 4.5. How is that going to affect this number? Will it make it bigger or smaller? Emma? Bigger. Because we have a smaller number here, we have to multiply it by more tens in order to get our decimal to move as many places. And in general, if we move our decimal to the left, our number is going to get bigger. So 4.5 times 10 to the 10. Let's go over these quick checks, at least some of them together. Madison, do the first one for us. Okay, and what do we get? Multiply 2 and 4. There we go. 8. That makes me feel better. I made a mistake earlier. Now you made one. Okay. Times 10 to what power?
9.
9. Do we need to make any adjustments in how we wrote our scientific notation? No, actually we don't. We want to have one digit to the left of the decimal. Right now our decimal would be here, right? So we don't need to move it at all. We're good. As long as it's only one digit, we don't have to move it. We don't have to write that decimal in. So we try to take that away. Okay, let's go on to number 2. Michael, oh, he's not here. Taylor, try number 2.
5.
Wait a second. We want to multiply the main numbers.
3 and 2.
Yeah, what is 3 times 2? 6. You did the exact same thing that Madison did. So we're all making each other feel better today. Okay, times 10 to what exponent? 13. Good. Do we need to make any adjustments to this? No. It's good the way it is. We have one digit to the left of the decimal. Number 3 looks a little bit different. Number 3 has just a plain old number that's not in scientific notation that we're multiplying times 1 in scientific notation. How do you think we would do that? If we use the rules that we've been given, how would we apply that to a problem like this? I'll take a volunteer to try this. Brian, go ahead.
Multiply 12 times 8.
Okay, what do we get when we multiply 12 times 8?
96.
96. And then what?
Then you put the times 10 to the 20th power.
Yeah, we just leave this. There's no exponents to add, so it's just times 10 to the 20th. So we only have to multiply it times that first factor. Now, Brian, are you okay with that form, or do we need to change it? Okay, what do I need to change it
You
to?
change 96 to 926. 10 to the 21st power.
Good. Okay, any questions about anything we've done so far? Megan?
What if we distribute the 12 and the 10 to the 25?
We actually do not do that when we're working in scientific notation. It's a little bit different because we're multiplying here, we're not adding, so that doesn't work to do that. Okay, that was a good question. Good thing to make sure we understand. Okay, let's look at an application. This is a science application. So it talks about, there's a lot of applications about light years because light years are really big. And so light year is actually a unit of distance, not a unit of time, as we usually think of year as a measure of time. A light year, oh, I have an extra R in the word distance. A light year is the distance that light travels in one Earth year. That's where the word year comes from. And it's about 9 times 10 to the 12th miles. A mile is 5.28 times 10 to the 3rd feet. And we want to know how many feet are in a light year. What are we going to do to these numbers to find out the answer? What operation do we need to perform? Anyone volunteer for this one? We know how long, how many miles are in a light year. We want to know how many feet are in a light year. And it tells us that a mile is 5.28 times 10 to the 3rd feet. Yes? We're going to multiply. So we have 9 times 10 to the 12th miles. And we know that a mile is this many feet. Now, how you can multiply this is using something called a conversion factor. If you're not sure what to do, you can think of it this way. There's 1 mile, or there are 5.28 times 10 to the 3rd feet in 1 mile. We'll be using conversion factors a lot when we do this. What happens when you multiply this is any word that you have on the top and the bottom is going to cancel out. So the miles will cancel out and we'll be left with just feet on top. So we know we're performing the right operation. If we divided instead, we'd have a mile on the top and a foot on the bottom and it wouldn't cancel out, so it wouldn't work. So we need to do 9 times 10 to the 12th times 5.28 times 10 to the 3rd. So let's not use a calculator for this. Let's do this by hand. Nathan, what do I need to do first?
Divide.
No, I'm multiplying. We already established that we're multiplying here. We're not dividing because we're kind of dividing by 1. We want to multiply this times this. How do I do that?
Calculator.
No, I'm not using a calculator. Okay, volunteer to tell me what I would do first. Right?
You need to write in the scientific form.
Well, it's already in scientific form.
With all of your
Oh, you want me to write it like just like this so you can see it nice, you mean?
You know, like 9.
No?
You know, like 9 zillion billion.
Oh, you think I should write it in standard form?
Yeah.
Okay, I could, but if I were doing it on the calculator, it would be too big anyhow. It would be really big numbers. What did we do on the last objective? Madison? Yeah, we have to multiply our main numbers. We have to multiply the 9 times 5.28. So I'm just going to move over here. I don't want to do that completely in my head, so I'm going to write it down. 9 times 8 is 72. 9 times 2 is 18, plus 7 is 25. And 9 times 5 is 45, plus 2 is 47. Now I have 2 decimal places, so I need to have 2 decimal places in my answer. So I get 47.52. How do I know what exponent? Nathan, I'm going to go back to you. How do I know what exponent to put on the 10?
Add the 12 and the 3.
Okay, and what do I get?
15.
15. Now, let's see. Anna, is this in the correct form for scientific notation?
No.
Okay, what do I need to change it to?
You need to change it to 4.752, and that makes it 10 to the 16th power.
Good. 10 to the 16th power. Okay, the next problem, I'm thinking maybe we should at least get started on this together. It says the speed of light is about 3.0 times 10 to the 5th kilometers per second. Use the formula D equals RT. That stands for distance, the D is distance, equals the rate times the time. To find the distance, light travels in an hour, which is 3.6 times 10 to the 3rd seconds. So we want to find D, which means we have to multiply the rate times the time. Okay, so I want you to take a second. I'm going to pause the video. So if you're watching this at home, take a second and try it yourself before you look at the solution. Okay, let's go over this briefly. So we have 3.0 times 10 to the 5th, and we're multiplying that by 3.6, oh, I missed my 5 there, times 10 to the 3rd. Okay, so when you did this, if you multiply your first 3 times 3.6, you get 10.8 times 10. When you add the 5 and the 3, you get 8. 10 to the 8th power. Some of you stopped there, but remember you have to make sure it's in the correct form of scientific notation, which means we're going to need to move that decimal over. So you should have gotten 1.08 times 10 to the 9th power. Yes?
I got 1.080.
Yeah, if you put a 0 after this, that's not it. You don't need it for scientific notation, because if it's at 0, that's an ending 0 after a decimal place, you technically shouldn't put it, but it's not wrong. Okay, last thing is choosing units with scientific notation. You'll have a lot of problems like this. Choose the most reasonable unit to describe the quantity. Then the fun part, we're going to use scientific notation to describe the quantity using the other unit. Okay, part A says the mass of a nickel is 5, and you have to decide if it's 5 grams or 5 milligrams. Now, we don't weigh ourselves using grams and milligrams. We're used to pounds and ounces. So I tell you here, it might be helpful to know a gram of sugar is approximately 1/4 a teaspoon of sugar. So if 1/4 a teaspoon of sugar weighs 1 gram, think about what unit you might use for the mass of a nickel. Yeah, Helena, what do you think? Would it be 5 grams or 5 milligrams? Well, is a nickel heavier or lighter than 1/4 a teaspoon of sugar, do you think? It's heavier. So you're going to want it to be more than a teaspoon of sugar, and a teaspoon of sugar is 1 gram. So it would make more sense. Milligrams are smaller than grams because there's 1,000 milligrams in a gram. So it's not going to be like 1,000 times less than a teaspoon of sugar. So we're going to want to use grams for that. And then here's the fun part. Now you have to express it in milligrams using scientific notation. So here's where using conversions comes in helpful. Have you guys done conversion factors in science yet? No? Converting units? You will. Probably, I don't know what year you do. I would guess next year you would do that. So if it's 5 grams and we want to know how many milligrams it is, we're going to multiply by what's called a conversion factor, where we say that there are 1,000 milligrams in a gram. So we need to make a fraction where we put grams on the bottom. So 1 gram is equal to 1,000 milligrams. So we can see from this the grams will cancel out. We can say this is 5/1. And we're just going to need to multiply our tops. If this were on the bottom, we would know we had to divide. But because it's on the top, we're just going to multiply. So we get 5,000 milligrams. And now I'm going to write that in scientific notation. Let's see, Morgan, what would this number be in scientific notation?
5 times 10 to the 3rd.
Good. So 5 times 10 to the 3rd milligrams is the same as 5 grams. Okay, Michael, try the next one. The length of a football field, is it about 91 kilometers or 91 meters? And the hint I give you is that a meter is very close to a yard, so this is about a meter. A kilometer is 1,000 of these. So a kilometer and a mile are not the same, but they're close. So when people run a 5K, that's not 5 miles, it's slightly less than that, but it's kind of close. So do you think the football field would be 91 of these or 91 kilometers? Meters, good. If you picked kilometers, that would be like saying the football field is like 91, close to 91 miles long, which is not true. So it would be meters. Now we need to convert this. So we're going to say 91 meters. We need to make a fraction. We're going to put meters on the bottom. But this problem says there are 1,000 meters in 1 kilometer. So we have to put the 1,000 meters on the bottom and the 1 kilometer on the top so that the m's cancel out and we're left with just kilometers. Okay. Now, what are we going to do? Are we going to multiply these 91 and the 1,000, or are we going to divide them? Avery? We need to divide. Because if we multiplied our fractions straight across, we'd get 91 over 1,000, which we would have to divide to give us an answer. So when we do 91 divided by 1,000, we get 0.091, which we then want to write in scientific notation. Trey, what would that number be in scientific notation?
9.1
Times 10 to the negative what?
second.
Yes, negative second, good. Now you could have written the 1,000 in scientific notation over here in the problem and gotten your answer that way as well. Okay, part C. A pencil is 7 centimeters or 7 meters long. Myra, now remember, this is a meter. So is a pencil 7 of these, or would it be 7 centimeters? 7 centimeters. A 7-meter long pencil would be very, very difficult to write with. I don't think it would fit. I think it would touch the ceiling. We could only use it outside. So it's going to be 7 centimeters long. So I have 7 centimeters times my conversion factor. I want to put centimeters on the bottom and meters on the top. It says that there are 100 centimeters in 1 meter. So I'm going to write 100 centimeters in 1 meter. Am I going to multiply or divide those numbers, Max?
Wait, how many?
Right here. Am I going to do 7 times 100 or 7 divided by 100?
Divide.
Divide. When I do that, what do I get? You don't need a calculator for dividing by 100.
0.07.
0.07. And how would I write that in scientific notation?
7 times 10 to the negative second.
Negative second again. Good. Okay, any questions about this? We have about 5 minutes left. I want you to do this exit ticket. I think I have enough cards. If I don't, some of you may have to write this on paper.
What we do in 7th grade?
7th grade, we're going to be talking about how to do this using calculators.
So we're going to know